in sync. The point is, it's a function where that thing in parentheses is my letter that's my input. You got what I'm saying? So, for example, in your textbook, they're going to use g of x. Actually, use g of t. How great are they? Okay, let's do the example. This is on page 232 if you follow your book, but you don't have to. The directions say evaluate. In other words, hey, find me a number. Evaluate this function, g of t. What's the function's name if I say g of t? What am I calling this function? It's not Bob, it's what? What's the output letter? The name of the function? G. What's going in? What's plugging into it? T. Because it's g of t. I know it's hard, and these are the hardest ones because I'm using letters you've not even seen before. So I understand it. It's kind of, you know. Okay, this will make it more clear if you see the function. Because, of course, on the right-hand side, it's going to just have the letter repeated that it's talking about. So this is the first part of your example. I'm going to keep writing, but I want to make sure we all understand what we're reading so far. We're reading our math book. What does the thing say? It says some function, hey, let's call it g, where t is our variable, our input variable. And by the way, let's define it equal to 3t squared minus 5t plus 1. Who cares? It could have been y equals with x is on the one side. Same meaning. Still just a relationship between two values we don't know. An input and an output. We show the input in parentheses. And the output we'll put is what it's equal to. Or what g is equal to in this case. The function. Okay, so I want you to evaluate this when t equals negative 2. And I'm going to add something. I'm going to say represent with functional notation. Since they're using the functional notation everywhere, stuff in parentheses, we'll go ahead and put our answer in that notation to make sure we all understand it. What's replacing my t? I have a t here. Did that just happen? Did I just scribble my pick on my little draw? There we go. So we have a t, and it's being replaced by what? Negative 2. Oh, so if I were going to use functional notation, I would say g of what? Negative 2. I'm replacing it. And I don't just replace it on the functional notation side. Where else do I replace that t? Everywhere I see it, on the other side too, sure. Good. Guess we should use order of operations. We don't have to play on the left, guys. This is all one thing. This is just my function where negative 2 is incorrect. That's all that means. So I'm just going to look at the right-hand side. Negative 2 squared, what do I get? Order of ops, 3 times 4 gives me, what's a negative 5 times a negative 2? Now what? 23? Oh, so my function g, when negative 2 is used as my input, is equal to 23. That's my answer. You guys okay? I know it looks a little messy at first, and so you'll have to get comfortable as you practice your homework. But the idea is still the same. Instead of me saying substitute, which I told you in the directions, that was kind of shady. I could have abbreviated the question and said find g of negative 2. I could have said the same thing. I didn't have to say when t equals negative 2. It's assumed that you understand this means that variable has been replaced with this number. That's the input. What's in parentheses. That's what's going in for my x, or my t, or whatever it is I'm using on the right-hand side. Just for the record, I could use anything I want. I'm sure in this class we'll probably learn about putting functions together. I can put anything I want in there. I could put a whole other function in there if I wanted. Just for kicks, who cares? Doesn't matter what I'm putting in there. Whatever's in parentheses, what happens to the letter on the other side? Here, I'm going to have fun with you guys and torture you a little bit. G of, you guys like boxes? I'm going to make a box. G of box. Box. I'll color my box black. So you guys don't think it's some weird empty little thing. G of box. Oh yeah, what's that mean? Everywhere I have T, what's going to go in its place? Why'd I color this thing with them? Now it takes me forever. So 3 times box squared minus 5 times what? Box. Or question mark. If you like speaking question mark, plus 1. Oh, okay. So literally all this notation means is whatever's in that parentheses goes wherever you had the letter. We don't care what it was. In the future, I'll give you hard stuff to stick in there. In the future, maybe I'll stick an x squared inside. What would that mean? Where would x squared have gone? Everybody had T? Oh, that'd be a fun one, wouldn't it? That'd make you probably pretty unhappy. But be comfortable. Be comfortable understanding what the notation wants you to do. Because very soon I'll start having you do that. I want you to understand that whatever's in these parentheses goes everywhere that letter was. Doesn't matter how easy or hard it is. That's the idea. By the way, you can't really simplify that, can you? That's just like having a letter. These things are not like terms. I could have put an X in there. It's the same as the T. Has to be a number to put it together more than what I've got there. Okay, that's enough of an intro to functional notation. Like I said, it will be revisited, so in your homework, go back and be looking at it. The last thing I do want to touch on with you guys, I want to come back a little bit to this domain and range stuff. I introduced it to you briefly when I was teaching you functions, but it's actually kind of a big deal. Remember for me, domain. Domain's what values? The X or the Y? It's so funny because these two words are so popular, and some people just freak out and just whatever. You say the word, they don't know what you're talking about. Make sure you memorize it. Domain means X values. Just that easy. Range means Y values. The good thing is, I mean, it's still ABC order. DR. D comes first in the ABCs, so does X. R comes later, so does Y. You know, I mean, if you're trying to find ways of making it map in your brain, it does work out. The whole consistency with ABC order. So if I listed a relationship for you, a relation. For example, on page 237, I'm going to list one. I'm going to look at number 50. And I'm going to say 26, 418, 638. By the way, could I have made you find these first, just to make the problem harder? Sure. I could have said, hey guys, your domain is, I could give you all the X values and make you find every Y one by hand. I'm just being friendly here. We're all friends. That sounds kind of creepy. Okay. Anyway, here you go. Lots of X's and Y's, right? We know the way it works when you look at ordered pairs is X comma Y. So if I asked you, hey guys, tell me what the domain is. What's the domain of this relation I've shown you? Okay. Now I can use, remember that set notation we learned about where you can use the curly braces and just list stuff out? That's what I'm going to do. So I said curly brace, and I'm just listing out the X's. 2, 4, 6, 8, 10. What about my range? What are my Y values? You guys are faster than I write. Okay. Sure. By the way, just for kicks, is this thing a function? I call it a relation, but is it a function? What am I looking for? If you're just looking at the numbers, you're making sure what doesn't repeat? The X. Does the X repeat? No, we're fine. Okay. If it did repeat, if it was not a function, could you still tell me the domain and range? Sure. I'm not asking you the function. I'm saying tell me the x values, tell me the y values. In fact, if it did repeat, just like that when you guys were doing the set stuff, you don't have to write the same thing twice for me. I know that 4 is 4. So you don't have to write it 5 times if it happens 5 times. You might want to notice it so that you can say, hey, this thing is definitely not a function. X's are repeating. But I know that if you've written it once, you see it happening. You don't have to write stuff over and over. Okay? And again, I want to make sure in your homework, they will give you problems where they say, this is the domain, find me the range. What are they telling you? These are the x's, find me the matching y's. How do you do that again? You plug in the x's, plug in each single one, just like you did on the quiz today, right? Where you plug in the function and get that output, get the y value or f or whatever the function's called. Okay. One thing they want you to start thinking about is values that are not allowed. Illegal values, that's what I like to call them. Things that are not okay. I've talked to you some about functions. Now I'm going to talk to you about, if you're looking at a function, what values break it. So this is the last part of our talk where I want to make sure you guys understand what's not allowed. What I mean by that is I've talked to you guys before about, you have real numbers, blah, blah, blah. There's some times when, even though the numbers and the system of mathematics has been defined, there are things that can make it break. Well, the stuff from your past that makes these functions break will still make them break today. I think the only one they're going to want us to look at, let me make sure, is the whole idea of dividing by 0. Later on, you may think a little bit more thoroughly about this, but the idea for right now is recall, in math we say you can never have what in the bottom of a fraction? You can never divide by 0. You can never have 0 in the bottom of a fraction. So what we kind of start caring about here is we say, you know what, we've talked about what functions are. Let's just kind of think a little bit about stuff that would break my function. Because I want everything to work nice. I don't want my Coke machine to break. You know what I'm saying? You don't want to put in like a coin from Mexico into this U.S. thing and the thing will lock up. We don't want that happening. And we already told you in the number world that dividing by 0 can't happen. That'll break everything. That's why we have the patch for it, where we say, don't do it. No answers. Stop right there. Sometimes you can get functions that have values not allowed. Sometimes you can get functions that have x's that are not allowed, that will break it. So that's going to be the last objective for today, to be able to recognize that. So let's look, for example. If I said, hey, here's my function, here's my f of x or my y or whatever you like to call it, and I'm going to say 2 divided by x. What's not allowed? X cannot be equal to what? Okay, so x equal to 0, not allowed. Why again? Why is this a restricted value from my domain? It would make an undefined function. You don't want undefined stuff happening. That's crazy. No way. Don't let it happen. Just make a little note, and then if somebody graphs it, they can know right there to erase the picture. But crazy stuff's happening. Because you can't get the output. Normally with a function, you want to be able to put in the output. Put in an x of 1 and what you get for your y. F of 1, let's see, 2 divided by 1. Oh, 2, okay. So with normal numbers, it plays nice. But there's one number that will make it break, and that's when x is 0. So we make a note. we say, hey, this thing plays nice. It plays like a regular function except when x equals 0. Sometimes the way I write it, I'll say or just x not equal to 0, because I like to see the not equal to, the not allowed that way. In a strict class, your teacher would want you to try to write it like that. And when you look in the back of the book, you'll see it written really officially. But the idea in this class is I just want to know you know those values. If you're comfortable just saying x not allowed to equal 0, x not equal to 0, that's okay with me too. It has the same value, the same meaning. Let's see if I can trick you. I'll give you 2 more problems. Let's see.